So we're on question 11. A particle is moving along a straight line with constant acceleration. Initially it's at O. After 9 seconds, P is at the point A, where OA is 18 meters, and the velocity of P is 8 in the direction OA. Show that the initial speed of P is 4. This it feels like it's got a suvat kind of thing going on. So it's constant acceleration, so it must be all to do with that stuff. So what happens? We've got an initially the particle is at O. We need to find the initial speed. We've got a final speed of 8. The velocity of P is 8 in the direction OA. So that's 8. The acceleration, we're not given the acceleration, are we? We'll find that in a bit. We've got a distance that it goes, and the distance was 18 meters. And we've got a time, and the time it took to do that was 9 seconds. So we've got U and A that we don't know about. So let's start by forgetting about A, U, V, S and T. S is a half U plus V times T. That's the Suvat equation that we remember for this bit. So 18 is a half of U plus 8 times 9. We need to rearrange that equation to find out what U is. Divide both sides by 9 and then times by 2. Oh, we've got 18 as a factor of both sides, haven't we? So 1 is U plus 8. Is that right? No, I've done that completely wrong, haven't I? That's 18 is U plus 8. That's better. That's not right either. 4. I knew I'd get there eventually. Divide both sides by 9 gives us a 2 on the left. Times both sides by 2 to get rid of the half gives us 4. Brilliant. U is minus 4 meters per second. There we go. Did it say speed or velocity? Oh, initial speed. So therefore, speed is 4 meters per second. Yes, because the velocity is minus 4, so the speed is 4. Find the acceleration during that time. So actually we're going back to the same bit. We're on part 2 now, or part 1b, sorry. Okay, so we've now got U is minus 4, V is 8, we need A, and T, let's do that one. V is U plus AT. So 8 is minus 4 plus 9A. So 12 is 9A. So A is 12 over 9, or 4/3 meters per second. Of course, I've taken a risk there, because if I'd got my initial speed wrong, I would have got the wrong answer there. So maybe a safer way of doing that might have been to use the V, A, S and T. So that would be S equals VT minus a half AT squared. And I could have done it without relying on U. But anyway.
I thought it's just there's a thing where if you get the first question wrong, but you use the second.
Yes, but we would have got the method mark, but maybe we wouldn't have got the because we could have done it without using that value of U. Okay, so that's 4 marks got. B is a point on the line such that OB is 10, as shown in the diagram. Show that P is never at the point B. Okay? A number of ways we could think about doing that. What could we do? We could find the furthest distance that it ever is from that point. We know that its acceleration is. We've got its acceleration now as being 4/3. It starts with So if we think about the start point of this, I think this would be a good way of doing it. It starts with a speed of minus 4. It has an acceleration of 4/3. So it's going to start by moving in the direction of B, isn't it? Its start speed is minus 4. It's moving in the direction of B, but it's accelerating in the direction of A. So there's going to be a point where the velocity is 0, and that's the furthest that it goes in the OB direction. So when v equals 0, I want to find how far it's gone at that point. And that's going to be the furthest distance towards OB. So that is S equals U, V squared is U squared plus 2AS that we're using. Oh, that's messed up there. So 0 is minus 4 squared plus 2 times 4/3 times S, which gives me that 0 is 16 plus 4/3 of S. Oh, I forgot the 2. Thank you. So 8/3. So 8/3 of S is minus 16 if I rearrange the equation, giving me that S is that minus 6? Minus 16 divided by 8/3 gives me minus 6. So the furthest away from O towards B it ever is 6 meters. But the distance OB is 10 meters. So never reaches B. There we go. And that's probably the way that I would have done that out of that bit. Is that okay? Now let's look at the next bit. So now things change and we've got an equation. The second particle moves on the same straight line but has variable acceleration. Initially q is at O, and displacement of q from O is given by that equation where A, B and C are constants. It's given that the velocity and acceleration of q at the point O are the same as those of P at O. Q reaches the point A when t is 6. Find the velocity of q at A. There's lots that we're going to have to work out here, aren't there? So let's think about what we've got. In part, is it part 3? So we've got x is at cubed plus bt squared plus ct. Right, this question is all about velocity and acceleration, isn't it? So that's about differentiating. So the velocity is dx by dt. If we differentiate that, that's 3 times at squared plus 2bt plus c. And the acceleration, which is dv by dt, differentiate it again, we get 6at plus 2b. Now we can start to piece together what the question said. So the question said that the velocity and acceleration of q at the point O were the same. Right, oh well that's good. So at O, that's when we begin. Presumably that means initially, but that's not entirely clear, is it? So when we begin, the acceleration, so that's when t is 0. A is got to be, what was A at the start? 4/3. So let's sub that in. 2b is equal to 4/3. So b must be equal to 2/3. And we started off by finding b. That was a good move. We're also told that when t equals 0, the velocity, what was our start velocity then? The velocity was -4 at the beginning of everything. So v equals -4. So that means that c is equal to -4. Okay, so we're piecing together what this equation is looking like. What else have we got to work on then? We're also told that when it reaches, q reaches the point A when t is 6. Now the point A is a displacement of 18. So when t equals 6, x equals 18. So that means that 6 cubed times a plus b times 6 squared, that's bt squared, plus c times t gives me an answer of 18. Uh, 6 cubed is 216. I've then got, what's that going to be? Is that 24? Minus 24 is 18. So the value of A, I think, is ending up being 18 over 216, which is a 12th. Is that a 12th? So my original equation is now 1/12 of t cubed plus 2/3 of t squared minus 4 times t. What was I supposed to get? And I'm supposed to find the velocity of q at A. Oh, hang on, so I need the velocity one, and the velocity equation is 3/12, so that's 1/4 of t squared plus 4/3 of t minus 4, and at A t equals 6, so the velocity is 1/4 of 36 minus 4/3 of 6, take away 4, which is, what is that, 9, take away 8 plus 4, is this right? No, it's not, is it? 1/4 of, should it be what? Oh, it is, yeah. And that should be minus the 4. What is going on there? Right, that's better. 13. Was that the right answer? Yes. There we go. There was a lot to work out there, wasn't there, to get all of those coefficients and work your way through it, but it was all, if you kept it together, kept it quite logical. There were a decent number of marks there, weren't there? 5 marks for doing that bit. There we go.